Presenting the Deep Extragalactic Experimental Prolonged Photospace Mission, otherwise known as the Deep Space Mission, presented by Rachel Boyle. Mission outline. Survey deep space like Hubble Space Telescope first did in 1995 using the new James Webb Space Telescope. The Webb telescope would be commissioned for a total of 3 days to stare at the same section of deep space with the goal of revealing the earliest galaxies created, along with a glimpse into the total unknown. We don't want to look at something specific. We want to specifically look at the unknown. In 1995, astronomer Robert Williams chose to use his 10% discretionary power as the director of the Space Institute to use Hubble to look at nothing. Many in the astronomy world were very skeptical about using the most sought-after telescope in the world this way, on the grounds that I hope we will gain something useful, even if I don't have any idea what that might be. This picture shows the Hubble Deep Field. That blank section of sky held much more than expected, though. The most distant galaxies ever observed were revealed. Fortunately, it was a risk that paid off. The new information gathered by those deep field images allowed us to see galaxies almost as old as the Big Bang. It is said that telescopes are actually time machines, as the light we see is from the distant past. Deep field images tell us more about the creation of the universe and shed light on our own galaxy's formation and life cycle. New technology and innovation has brought us an even more powerful tool, the James Webb Space Telescope. We believe it is again time to take a risk on nothing in hopes of seeing the creation of everything. The key to our proposed deep space mission is the new Webb telescope and all of its amazing features and capabilities. There has not been another telescope quite like it. The Webb telescope will be about 100 times more powerful than the Hubble Space Telescope. Webb project scientist Amber Strawn said, "It is by far the biggest telescope that NASA has ever attempted to send into space. Top to bottom, it stands about 4 stories tall, and it has a gigantic kite-shaped sun shield that's about the size of a tennis court. It will be equipped with infrared capabilities and have a sun shield to keep it cool." You can see these pictures. There's a comparison of the Carina Nebula on the left in visible light and on the right in infrared. Here is a picture of the James Webb Space Telescope. Why are infrared capabilities important? In the previous images, you can see the benefits of an infrared telescope when looking at the most distant objects in space. Interstellar dust doesn't interfere with infrared wavelengths, so we can see more stars. Secondly, the more distant an object in space is, the more it is affected by the universe's expansion. Visible light wavelengths from the earliest galaxies has been stretched, redshifted, and can only be seen via infrared technology. To meet our goal of seeing the oldest galaxies, this is a must. Another important upgrade is the Webb's primary mirror. It is considerably larger than the Hubble's and will provide nearly 6.25 times the amount of collection area. This will greatly increase the amount of light collected and will give us a more detailed picture. Location, location, location. The James Webb Space Telescope will not be in orbit around the Earth like the Hubble Space Telescope is. It will actually orbit the Sun, 1.5 million kilometers away from the Earth at what is called the second Lagrange point, or L2. What is special about this orbit is that it lets the telescope stay in line with the Earth as it moves around the Sun. This allows the satellite's large sun shield to protect the telescope from the light and heat of the Sun and Earth and Moon. Webb's position out at L2 makes it easy for us to talk to it. Since it will always be at the same location relative to Earth in the midnight sky, about 1.5 million kilometers away, we can have continuous communications with it as the Earth rotates through the deep space network. It's a visual of what the James Webb Telescope will look like in space compared to where the Hubble was. This graphic shows just how far back we hope to see compared to previous attempts. The aforementioned combination of features will hopefully provide all the tools we need to successfully use the James Webb Space Telescope to complete our proposed deep space mission. Thank you for your consideration.